Okay, so our next topic is we are going to evaluate a new constraint. So let's see what's this. Our example was here, right? We have two resources and we have two activities. Basically, we want to allocate resources to activities. We know how to evaluate a new option, a new activity. Now the thing is that what if we now have a new constraint, something like this, okay? So you may have all kinds of new constraints. For example, you suddenly realize one of the products or both products, they need some kind of the third resource. That's possible. Or in the past, you have the products always need the third resources. But in the past, you have unlimited supply of this third resource. But now the supply is no longer unlimited. Okay? Or there are some new law, new regulation, whatever. So it's always possible that our activities are still there. We just have two options, two products to produce, but we are subject to new constraints. We need to somehow have a way to deal with this kind of situation. So the way is the following. Intuitively, we should at least try this. Originally, we have our optimal solution, right? Which is this one, x1 and x2, that should be 2 and 2. We should try this to see whether this satisfies the new constraint. If our original optimal solution is still feasible, then it would of course be optimal, again, in a new problem. But of course, we are not in this case, in this example, because our x1 is 2, which is greater than 1, the upper bound of our x1 in the third constraint. So we need to somehow have a way to deal with the case of infeasibility. Okay, so let's look at Tableau again to get more ideas. Our optimal Tableau is here. Okay, so when we are solving our previous original problem, eventually we get to this optimal Tableau. Our x1 and x2 are basic. S1 and S2 are non-basic. x1 and x2, they are 2 and 2. Okay. The idea that we want to create or follow is somewhat similar to what we do with evaluating a new variable. When we evaluate a new variable, basically we take a look at that new variable and try to calculate its reduced cost, right? That's pretty much what we do. So here, we somehow want to expand our Tableau to get our third row. And basically, we want to see what's going to happen with the third row. And that may somehow help us to start from this Tableau and do some more iterations to get to an optimal solution. All right, so with a new constraint, we will also have a new Slack variable. Let's call it S3. We're going to see what should be our new Tableau. So again, we need to use that matrix representation to do this. So what we know is that we have a new constraint, and also we have a new variable, which is something we call S3. So in this case, probably we will say, okay, let's consider S3 as our new basic variable. Well, why is that? Previously, you probably remember that we are having two constraints and 4 variables, right? Now we have our third constraint, so we have 3 constraints here, and we have 5 variables here, right? In that case, we need 3 basic variables, okay? So we have x1 and x2, they are basic. We have s1 and s2, they are non-basic. Now we have a new one. It's natural to add it into the basic part because we need 3 basic variables, all right? So let's say S3 is basic. If that's the case, then all we need to do is to follow the very standard way of doing matrix representation. We have the index set B, we have the set N, we have all those A, B, A, N, C, B, C, N, small b, and that allows us to calculate this AB inverse AN, AB inverse B, and the reduced costs. So I don't want to repeat this again. All I want to do is to just give you 1 or 2 examples. For example, let's take a look at AB. To take a look at AB, we need to go back to our new program. Our new program is here. We can see that this is basically, we have three constraints, and we're going to add S1, S2, and S3 to expand this particular program into a standard form. Okay, and if we do that, our matrix A may be constructed in this way. All right, so this is our matrix A. If I say x1, x2, okay, x1 is here, x2 is here, and x5, I should say s3. If I say these three variables are basic, then the first column, the second column, the last column, that should become my AB. Okay, so my AB would be 111, 120, and 001. We can see it's indeed 111, 120, and 001. So AN, the same thing, B, CB, CN, whatever, it's just doing this way to collect those numbers and put them into the right matrices. And then we may be able to calculate all the other things we need, and that gives us our new tableau. So x1 and x2 and the s3, these are basic variables. Basically, all we want is that we want to calculate numbers here and the numbers here, right? This is for the new constraint, this is for the new variable. We want these numbers, but of course, while we are doing those AB inverse AN whatever, we actually calculate the whole matrix. So anyway, that's something that helps us to bring us a new tableau. Okay. So this tableau actually tells us a lot of things. It tells us that, well, this is not a simplex tableau because you have a right-hand side value that is negative, which should not happen in your simplex iterations. In your simplex iterations, typically you start from a basic feasible solution where all these right-hand side values are non-negative. And then you move to our next corner point, next basic feasible solution, next extreme point, and so on and so on and so on. As long as it is a basic feasible solution, all its right-hand side must remain non-negative. And actually, we know the whole idea of pivoting, of ratio test, is to make sure that all your right-hand side remains non-negative. Okay? So it's impossible for us to see a right-hand side column contains a negative value. This somehow suggests us that this particular basis is not a basis. This is a set of candidate basic variables. But given that it's infeasible, it is actually something we do not allow. This does not give us a basic feasible solution. Somehow we need to fix it. What should we do? Later we will see how to do this.